Hello students, this is Dr. Diaz and let's keep talking about gas. In the previous class we talked about gas, what was the variables that was affecting the pressure of the gas, and now we're gonna work with the variables that affected the gas behavior, like volume, and let me grab my pen over here. So we have volume, pressure, temperature, and number of molecules. And of course, in the beginning, like in the first class, we talk about the volume. When the volume increased, what happened with the pressure? Remember? When the volume increased, the pressure decreased, right? So now the scientists start studying how the variables affect the behavior of the gas. And of course, when you study a variable, if you want to study the variables, you need to keep some constants in order to see and to study, evaluate the changes in that variable and how gonna affect the pressure or the gas behavior. Okay, so some scientists put all those together, like, okay, I'll keep those constants and we'll study the pressure, the effect of the pressure and the volume. And this is what they did. That took a long time. So the gas laws are essential principles in chemistry that describe how gas responds to changes in the pressure, volume, temperature, and the amount of gas present. They help us understand and predict the behavior of gas under various conditions. And this is very important in the industry, and can be engineering, can be in the pharmaceutical industry, and everywhere. And the lessons in this lesson, we're gonna study like 4 primary gas law. Boyle's law, which relates pressure and volume. Charles' law, that relates volume and temperature. Gay-Lussac, that relates pressure and temperature. And the combining gas law, that brings all the variables together. Okay? So Boyle's law is the one that you're going to start with, that study pressure and volume. And this, he starts studying in the lab using mercury liquid, and he saw that the moment that he divide the volume by 2, like decrease the volume by 2, the pressure double. So the decrease the volume, the pressure increases in the same proportion. So if you see here the graphic, you see that when you have a high pressure, you have a very low volume. So here says the volume is inversely proportional to the pressure. This is the symbol that we use to proportional. Okay, so you have, I think you have seen this a lot of times. So that statement here says the volume is inversely proportional to the pressure. So that means when one increase, the other will decrease. Okay, and this came the law. And he observed that if you have in the same experiment, so it's a closed system, okay, so the gas will not escape. This will be constant. Pressure times V will be constant. So if I increase the pressure, I will decrease the volume. So the value will be the same at the end. So this is why it's constant. So, and this statement, like the equation over here, the only thing that we did over here is multiply both sides by P. So cut off over here. So I have the constant equal PV. So that is the formula. So I can say that P1V1 is equal P2V2. That is Boyle's law. And how to apply. So you're gonna need some algebra over here, right? So if I want to isolate, so I have P1V1, P2V2, and when I want to find V2 and have all the data P1, V1, and P2. So I'm gonna divide both sides by P2. So I'm gonna cut over here. So I'm gonna have V2 equal V1 P1 divided by P2. Okay. The same thing that you're gonna do if you wanna isolate P2. So I have a P2 over here. So I'm gonna divide by V2 on both sides. So it's algebra. And remember, that was a requirement to do chemistry, know a little bit of math. So let's practice, because I think the best way to learn is to practice. Here you're going to start with the Boyle's law problem, a very simple one. So we have here a 3.50 liters sample of methane gas exert a pressure of 1,550 millimeters mercury. So I have volume 1 and I have a pressure 1. And what is the final pressure if the volume changed to 7 liters? That is the volume 2. So I know when I have PV, so I know that I'm talking about Boyle's law. And I know the Boyle's law is this one over here. And also I learned concepts that when I increase the pressure, the volume will decrease. So when I decrease the volume, the pressure will increase. What happened over here? So my volume 1 is 3.50. My volume 2 is 7 liters. So what's going to happen with the pressure? Will decrease, right? Because I increase the volume. So I know that at the end of my problem, I need a lower pressure. So we start with the formula, organize the formula to find the P2. So put my data on the formula, and I have 775 millimeters mercury, exactly the half, because I increase double, so I decrease double the pressure. So that will be our answer, and the concept here helps you a lot. If you get like a higher pressure, you know that you did something wrong. It can be math, can be the organization of your data. So first, organize your data. My suggestion is write down, like, okay, I have this, the pressure, oh, sorry, under 15 millimeters mercury. Pay attention to the units. If I have liters, the other volume must be liters. If I have ATM, the pressure must be all in ATM. So just pay attention to that. So I have this over here, and I have a pressure 2 that you don't know. So first organize your data, so then you apply the formula, okay? So let's do one more together. So I have here 125 milliliters sample of argon gas. Change the pressure from 705 millimeters mercury to 385 millimeters mercury. If the temperature remains constant, what is the final volume in liters? So I have a volume 1, which is 125 milliliters. I have my pressure 1, which is 705 millimeters mercury. I have my volume 2. No, I don't have. This is what I want. And they ask in liters, be careful. And then I have a pressure 2, which is 385 millimeters mercury. Okay, what happened to the pressure? Decrease. So if I decrease the pressure, what happened with the volume? Remember, if I decrease the pressure, the volume will increase, because we know the volume is inversely proportional to the pressure. And we know the formula, P1𝑉1 is equal P2𝑉2. What I want is V2. So I'm gonna divide both sides by P2 over here, and my formula, so I'm gonna cut over here, so I'm gonna erase this, and I'm gonna have V2 equal P1𝑉1 divided by P2, right? Oh, so that is my formula. So V2 will be, I have the pressure 1, 705 millimeters mercury. I have my volume 1, 125 milliliters, and I have my pressure 2, 385 millimeters mercury. Can you do your math, please? I can do it here. I'm gonna use my calculator over here. Okay, so I have 705 times 125, and I will divide by 385. So, and that will give me, wait. I don't want to do anything wrong over here for you. So V2 will be 2, this is what I got. Let me see, to 705. Okay, so volume 2, 705 and 125, and I have 385 over here. Okay, so now I have 228.90 milliliters. But here, see, it's 3 significant figures, so it will be 229 milliliters. And to go to liters, so how we get to liters? 125 milliliters to liters will be 1000 milliliters. It's 1 liter, so it will be 0.125. So here will be the volume 2, 0.229 liters. Okay, so you need to convert the units because the problem asks you to do so. Okay, what else? Let's keep it going. What is important here? So maybe you're asking yourself, what do we need to know that? It doesn't matter if you go to engineering course or to medical field. This is very important. So what happens if a scuba diver ascends happily from a deep zone toward the surface? So what happens? The pressure will decrease very fast. And this can cause the gas molecules expand because the volume will increase so fast. So these gas bubbles can go on to cause damage to the diver organs and can cause death. He can die. So another very similar example is the fish, the deep sea fish. So the deep sea fish died after reaching the surface of the water because the pressure, okay, due to the expansion of dissolved gas in their blood. So this is how important it is to understand the concept of gas, okay? So